All right, here is the video for our test review for Unit 5G, more radicals. So in this first problem, we are distributing the radical 3. So remember, when multiplying radicals, you multiply the outsides together, the insides together. Now this first multiplication, this radical has a 1 on the outside, and this radical has no insides, but really it has a radical 1. So when you're multiplying the outsides, you get 1 times 4, and the insides you get 3 times 1. Or what I'm just going to call from here on out smushing. Smush the radical 3 and the 4 integer together. So 4 radical 3. All right, let me erase that. Okay. So now I have plus, and when I multiply these two radicals together, I'm going to multiply the 1 times the 3, and inside is 3 times 5, which is 15. And you want to look to see if you can simplify the radicals, which you can't, and then if these radicands matched, we could add these together, but they don't, so we're just going to leave it like that. And number 2, distribute the radical 5 here. That's going to give me 4 times radical 5 times 8 inside. And then distributing to the second term gives me the 2 out front, and inside I have 5 times 12. So now I'm going to factor the 8 and the 12 in here and simplify those radicals. So I still have this 5. 8 I'm going to factor into 4 times 2 because 4 is a perfect square that I can square root. And then over here I have the 5, and then 12 I'm going to factor into 4 times 6 because 4 I can square root. So taking the square root of 4 is 2 times the 4 that's already out front. It's going to give me 8 outside, and inside I have 5 times 2, which is 10. Plus square root this 4 gives me 2 times the 2 out front is 4. And here I have 30. I do want to double check that if I factored 6 into 2 times 3, that it wouldn't create a pair with the 5. And it doesn't create a pair, so I'm okay. There's no more simplifying I can do. So that 5 times 6 is 30. Check if your radicands match, and they do not. So no more work to do here. On number 3, I have this group squared, and that means times itself. So this is going to be 2 radical 5 plus 3 radical 2 times itself. So I'm going to start by distributing the first term. 2 radical 5 times 2 radical 5. That's the outsides are 4. And the insides are 5 times 5. Then multiplying these two together, the outsides give me 6, and the insides give me 5 times 2. So now I'm going to distribute the second term here. The outsides multiply to 6, and the insides are 2 times 5. And then I'm going to distribute 3 radical 2 to this 3 radical 2. The outsides are 9, and the insides are 2 times 2. So now I look for any more factoring I can do, or whether I have pairs. So in the first term I have a pair of 5s. I'm going to pull out 1. Times that 4 is 20, and there's no more radical because I simplified everything inside. Here, nothing simplifies in the radical, so this is 6 rad 10. This one also is 6 rad 10. And then the last one, there's a pair of 2s. Times the 9 gives me 18, and there's nothing left in the radical. So now I look for like terms. 20 and 18 can combine to 38. And then 6 rad 10 plus 6 rad 10 is 12 rad 10. On number 4, I have a binomial times a binomial again. So I'm going to start by distributing 7 first. So that becomes 7 times 2, which is 14. And 7 times negative 3 rad 11 is negative 21 rad 11. Now distribute the second term. So multiplying these insides is 2 rad 11. And then multiplying at the ends is radical 11 times 11, and it's, oh sorry, there's a 3. Hold on. So it's a positive times a negative, so that's negative, and then 3 outside and 2 11s inside. So I can pull 1 11 out here and multiply by that. That's going to be a negative 33. So then let's see what we can combine. We can combine 14 and negative 33. That is negative 19. And then negative 21 rad 11, positive 2 rad 11 is negative 19 rad 11. All right, so these 4 problems reviewed the distributing radicals. So now we're going to talk about rationalizing the denominator. Remember, we don't want to leave a fraction that has a radical in the denominator. So we want to get rid of that down there. So we do that by multiplying it by itself here in this problem. So I'm going to do times radical 5 on the bottom and times radical 5 on top. So multiplying the numerators gives me 7 square roots of 55. And then on the bottom, square root of 5 times square root of 5. Remember, the radicals will cancel out, leaving you just 5. Really what's happening is you have 5 times 5 or square root of 25, and either way that simplifies to 5. And if 7 over 5 could simplify, we would do that one more time, but they don't. Now over here, the difference is that I don't have a single radical on the bottom. I have it paired with an integer, so there's a binomial. And so when we did that part, we talked about multiplying by the conjugate. The conjugate is when you keep the terms the same and you change the middle sign to its opposite. So that would be 3 plus radical 3, and whatever you do to the bottom, you also have to do to the top. So this becomes another FOIL or double distributive situation in the numerator. So 2 times 3 is 6, and 2 times rad 3 is 2 rad 3. So now I'm going to distribute the second term, this rad 3. So radical 3 times 3, positive 3 rad 3, and radical 3 times radical 3 is radical 9. And in the denominator, you can do FOIL or double distributive. That's fine. We also had this shortcut where you square the first term, square the second term, and subtract them. So we talked that day about if you FOILed the conjugates, the 2 middle terms would drop out. So since you already know that pattern is going to happen, you can just skip that. Square the first term, square the last term. All right, so I'm going to clean this up a little bit. In the numerator, square root of 9 is 3. So I'm going to add 6 and 3 right there, those two things, that's 9. And then these middle terms right here have the same radical, so I'm going to do the math on the coefficients. 2 plus 3, that's 5 square roots of 3. And then in the denominator here, I have 3 squared is 9, square root of 3 squared is 3, that is 6. So my denominator is 6. And we cannot simplify this fraction. We talked about how when you simplify and you have 2 terms in the numerator, 1, 2, 3, all 3 of these things have to be able to simplify by the same term. But there is nothing that 9 and 5 and 6 have in common. So we are done here. And then on the back, we have another conjugate problem here. Multiply by square root of 5 minus 2 top and bottom, because I'm doing the conjugate of the denominator, which means keep the terms the same but change to the opposite sign. So this is a distributive here, 5 rad 5 minus 10. And this is the shortcut where you square the first term, square the second, and subtract. That's our difference of two squares, just the opposite direction from when we were factoring. So that gives me 5 radical 5 minus 10 on top, and on the bottom I have 5 minus 4, which is 1. So that's 1, or just 5 rad 5 minus 10. Now we're going into solving radical equations. In this one, the radical is already isolated, so I'm going to square both sides. 31x equals x squared. Get it equal to 0 by subtracting 31x. Factor out a GCF of x. Set your factors equal to 0. Solve them. This first one's already solved. The second one, I have to add 31 to both sides. And then you want to take time to take those, plug them in for your x's here, make sure it gives you a true statement. And both of these will give you a true statement. So they're both solutions. On number 9, we have to isolate the radical first by adding a to both sides. Now that it's isolated, I can square both sides. Now I need to get it equal to 0, so keep the a squared on the right, and then move the stuff on the left over by doing the opposite. You're going to factor what multiplies to negative 35 and adds to negative 2, and it's negative 7, positive 5. Set them equal to 0 and solve. Plug those into the original equation, check to see if they make a true statement. And the only one that does make a true statement is a equals 7, a equals negative 5 does not check out. And then for this last problem, T is time, D is distance. We're given a construction worker drops a nail from a building 64 feet high. How long does it take? So we're looking for time and we're given distance. So I'm going to plug those things in. 64 divided by 16 is 4. The square root of 4 is 2. And my units are seconds.